In this section, we will be solving a system of linear equations using the substitution method. Now, example 1, we have 3x minus 2y equals 16, 2x plus y equals 20. Now, in the substitution method, step 1 really is the most important step in the entire process. You want to solve one of the equations for one of the variables in it. Now that means you can solve for this x, this y, this x, or this y. Now you want to choose wisely. If possible, you want to make this process as easy as you can. So looking at the choices here, I'm going to solve the second equation for y. If you notice, y has a coefficient of 1, so when solving we won't have to divide through by a number and we won't have any fractions running around in our answer. That'll just make the process easier as we move forward. So we're going to take this equation, this is step 1, 2x plus y equals 20, and we're going to solve for y. So we're going to subtract 2x from both sides. That will give us y equals 20 minus 2x. Now step 2, substitute the expression obtained in step 1. So this right here, the 20 minus 2x, into the other equation. So we're going to take 20 minus 2x and replace it for y here in the first equation. So step 2, we have 3x minus 2 times replacing y with 20 minus 2x. And then it's equal to 16. Step 3, solve the resulting equations. So the first thing you want to do here, get rid of the parentheses by distributing. We're going to distribute the negative 2 through here. So we're going to have 3x, negative 2 times 20 is negative 40, plus 4x equals 16. So combining the like terms, 3x plus 4x is 7x minus 40 equals 16. Adding 40 to both sides, we wind up with 7x is equal to 56. Dividing both sides by 7, x is equal to 8. So we found one of the coordinates of our solution. Remember, the solution to a system of equations is always an ordered pair. It's the point at which the graphs intersect. So we have the x coordinate, we need to find the y. So step 4, substitute this result into one of the previous equations, which means we could substitute it in to the given equations or the equation obtained in step 1. I'm going to use the equation from step 1. So y equals 20 minus 2x, replace x with 8. And find y. So 20 minus 2 times 8, y equals 20 minus 2 times 8 is 16, y equals 4. So our solution is the ordered pair 8, 4. And last step, step 5, you want to check. So we have our ordered pair, there's 8, 4, and our first equation, 3x minus 2y equals 16, replacing x with 8, y with 4. 3 times 8 is 24 minus 8 equals 16. 24 minus 8 is 16. 16 is equal to 16. So the ordered pair 8, 4 satisfies the first equation. You have to try the second equation as well. 8, 4. And the second equation, we have 2x plus y equals 20. So 2 times, replacing x with 8, y with 4, equals 20. 2 times 8 is 16, plus 4. 16 plus 4 is 20, equals 20. So it checks. So we know that the ordered pair 8, 4 is a solution to this system of equations. Example 2, solving this system using the substitution method. Again, step 1, you want to solve one of the equations for one of the variables in it. So I could solve for this x, this y, this x, or this y. Now you want to look for a variable that has a coefficient of 1. That will just make the entire process easier. So I'm going to solve the second equation for x. So here we have, this is step 1, x minus 2y equals negative 3. We're solving for x, so I'm going to add 2y to both sides. So this gives us x equals negative 3 plus 2y. Step 2, in the equation you did not use for step 1, plug that expression in for the variable. So here we have 5 replacing x with negative 3 plus 2y minus 4y equals 9. Step 3, solve the equation. So eliminate the parentheses. You're going to distribute the 5. 5 times negative 3 is negative 15 plus 10y minus 4y equals 9. Combine the like terms, so negative 15 plus 10y minus 4y plus 6y equals 9. Add 15 to both sides. We wind up with 6y is equal to 24. Divide both sides by 6. Y is equal to 4. Now we need to plug this result into either one of the given equations or your result from step 1 to find the x-coordinate of your solution. So this is step 4. I'm going to use the equation obtained in step 1, x equals negative 3 plus 2y. So x equals negative 3 plus 2 times 4. X equals negative 3 plus 8. X equals 5. So our solution is the ordered pair 5, 4. And check. Step 5, you always want to check your answer. So take the point 5, 4 and plug it into both of the given equations. So we have 5x minus 4y equals 9. And we're going to do the same. There's 5, 4 to the other equation. X minus 2y equals negative 3. So starting with 5x minus 4y equals 9, replacing x with 5, y with 4, we have 25 minus 16 equals 9. 25 minus 16, 9 equals 9. So the 0.54 does satisfy the first equation. Try it in the second. Here we have replacing x with 5 minus 2 times 4 equals negative 3. So 5 minus 8 equals negative 3. Negative 3 equals negative 3. So it checks. So we know that the ordered pair 5, 4 is a solution to this system of equations. Now example 3, same thing. First step, we need to solve one of the equations for one of the variables in it. I'm going to choose the y up here in the top equation. So we have 3x plus y equals 5. Subtracting 3x from both sides, y equals 5 minus 3x. Substitute this into the other equation. So we have 6x plus 2y. Y is replaced with 5 minus 3x equals 11. So we have 6x plus, distributing the 2, 10 minus 6x equals 11. Combining the like terms, we have 6x minus 6x That leaves us with 0x. 0 times any number is 0, so the x's are gone. And we're left on the left-hand side with just 10 equals 11. Now, looking at this statement, this is not true. And if you think about x, there are no x's left in this equation. So it doesn't really matter what x is. This will never be true. So in this particular case, it doesn't matter what x is. There is no solution to this system of equations. If you were to graph this system of equations, you would notice that both of these lines would be parallel. There is no solution. Example 4, here we have x minus y equals -1 and y equals x plus 1. So solving one of the equations for one of the variables in it, if you look at the second equation, it's already been done for you. Y has already been isolated. So step 1 has already been done for us. We can skip to step 2 where we plug it in. So we're going to have x minus, replacing y with x plus 1, equals -1. Solving the equation, we have, getting rid of the parentheses here, x minus 1 equals -1. X minus x, again, that is 0, so the x's are gone, and we're left with -1 equals -1. That is true. And there are no more x's left in the equation, so no matter what x is, -1 is always equal to -1. It's always true. So in this particular case, you have the situation where there's infinitely many correct solutions. All right, if you were to graph these two lines, you'd notice that they were, in fact, the same line. So there are infinitely many solutions to this system of equations.